Hi. Sam is a graduate student from Cornell University. I think Sam's major in mechanical engineering, and Josh is graduate from Cooper Uni, and now he's a graduate student from the Purdue University. So today, he's going to help us understand how you can the strategy and the tips about preparing the SAT SAT math review. So now I'm going to hand the program to Sam and Josh. Okay, Sam and Josh, please unmute yourself. You can take over now.
Hi, everyone. Thanks for coming today. I'm going to start sharing my screen here. So what Josh and I are doing today is we're going to go over 38 questions from a practice test. Josh will put the link right now in the chat. This is a practice test that's on the College Board website, practice test number 8. And we're doing section 4, which is the calculator section. And like Cecilia said, we'd like if you guys could keep the questions to the end if we get to our Q&A session, because we're going to try to breeze through these with while saying our thinking process out loud. And if there are any questions at all, just please note which number question we're on so that you have it available for the Q&A session. And so I guess without further ado, we will get started. This is the reference page that you are given in your section. So just to familiarize yourself with it, a lot of different geometry, triangles, different 3D shapes. So we might refer to this later, we'll see. But Josh will get us started with question 1. Here we go.
All right, let's dive right into it. So the first question asks, 1 pound of grape costs $2, and at this rate, how many dollars will C pounds of grapes cost? So intuitively, we can simply say it's 2C. However, if you guys aren't convinced, we can simply set up a simple proportion. We can have 1 pound of grapes over $2 equals C pounds over X dollars. And we can simply cross multiply these terms and arrive at 2C. And that's A.
Thank you, Josh. I want to move to question 2 real quick now. This one is a pretty easy question, not really math. It's almost really just being able to see and read a graph. So Tracy collects, sells, and trades figurines. She's tracking the number of her figurines in this collection in the graph below. On what interval did the number of figurines decrease the fastest? So we can quickly go through the choices, but it's even easier just to look at the graph. So we're not even going to look at the choices yet. So decrease means downward sloping. So the only 2 possible answers are right here. Right? So we're looking at 1 and 2, 3 and 4. So it's got to be one of these answers. It cannot be B and it cannot be D. So the fastest decreasing, in my head, I'm thinking that means it is dropping off as quickly as possible. In other words, it's the steepest downward slope. And without doing any math, just by kind of comparing these slopes here, this versus this one. Sorry, that's a little messy. This is definitely the steeper one. And just like that, pops out the answer C. Move on to number 3.
All right, in question 3, we have a random sample of 200 cars of a particular model, and 3 have a manufacturing defect. And the question asks, at this rate, how many of the 10,000 cars of the same model will have a manufacturing defect? So again, in this question, we can set up a proportion. We can have 3 defects out of 200 cars equals X over 10,000 cars. The question is asking how many defects will there be in 10,000 cars. So we can cross multiply these terms and have 3,000 equals 200x, and dividing 200 from both sides, we arrive at 150.
Good, Josh. Yeah, so these are pretty simple problems. They're going to get a lot tougher pretty soon. So here we go, number 4. So here's one. I'm going to zoom out just a little bit. So number 4 asks us, the scatter plot above shows the data collected on the lengths and widths of these petals of this sort of flower. A line of best fit for the data is also shown. Based on the line of best fit, if the width of an iris petal is 19 millimeters, what is the predicted length in millimeters of the petal? So actually, what I'm looking at right here, first we just got to understand what the graph is saying. This is the width as the independent variable and the length. They give us the line of best fit equation right here. So I'm just going to rewrite this on the side. Y equals 1.67 x plus 21.1. And so this is telling us, just to break it down, y is the length of the petal, x is the width. The question asks us to predict, using this model, using this equation, what is the length of the petal, of a petal that has 19 millimeters width. So this one is pretty straightforward. You just have to plug in the 19 into x. So we'll have this here, 1.67 times 19 plus 21.1. And if you do the math, this will come out to answer C. And this is obviously a calculator problem. And this is a calculator section. You want to be able to discern whether it's a good time to use your calculator or not. So this is really that first problem that we really had to use our calculator. So I will note that here also, calculator. Okay. All right, let's go to question 5.
So in question 5, we're given a triangle, and the question says that lines L and M are parallel, and they give us the degree values for both y and z, and it asks us what's the value of x. So we know that for triangles, all the angles inside the triangle sum up to 180 degrees. Let me wait for Sam to finish writing it.
Yep.
Okay. And we can see that y and z are not in, they don't look like they're in the same triangle. However, we can think and discern that this is a corresponding angle. You can either put y up into the smaller triangle or put z into the larger triangle, either way. So now we have the two values, two angle values in one of the triangles, and simply we can do 180 minus y minus z and arrive at x. So here, because y is 20 and z is 60, that gives us 100.
Just gonna finish writing up the work here. There we go. 100. So note this, also very important. This figure is not drawn to scale. I'm sure a lot of you are looking at this and you might say, oh, that kind of looks like a 90-degree angle, or maybe it's even less. So that's just very important. Don't trust what you see. You can trust that these are parallel lines and that these are corresponding angles, this y and this new y that I've written here in red. But just remember, this figure is not drawn to scale, so don't trust that. All right, thanks, Josh. Let's move to number 6. This is a modeling type of problem. This basically is testing whether you can read a word problem and just translate it to some simple algebra. If you look at the answer choices real quick, that's what I like to do first here. They're asking you for 2 equations. So in your head, you're starting to look for 2 different equations that can pop out of this word problem. So let's read it together. The two types of tickets were sold for a concert held at this amphitheater. The tickets to sit on the bench are $75 each. So let me just write here, bench equals $75. And to sit on the lawn is $40. All right. Organizers of the concert announced that 350 tickets have been sold and that $19,250 have been raised. So that's important too. So total sold is 350 tickets. So that's the number of tickets. And 19,250 is the total sales, we'll say, total sales. So this is asking us to make a system of equations, just basically means make 2 equations, right? To find the number of tickets for bench seats, which are B, they're telling us this is now called a B seat, and that a lawn seat is L. So I'm not even gonna look at the choices here. We could, but it is a good exercise to do it on your own first. They're telling us 350 tickets were sold. So that means B plus L. So that's B, the number of tickets, bench tickets sold, plus L, the number of lawn tickets sold, has to equal 350. So just by that, you can already eliminate C. This does not work. Step 2, we know that the total sales are 19,250. So the number of bench tickets times the amount that a bench ticket costs would give us how much they made from the benches, the bench seats. If we multiply these together and add it to L, the number of lawn seats, times the cost of a lawn seat, we should get 19,250. So convince yourselves this makes sense. And if we kind of look at the answers, that does not look like A. B almost looks like it, but notice they're flipped, right? That 75 should be with the B, and that should lead us to answer D. All right, move right along.
Question 7 asks, in the xy plane, the graph of the following equations is aligned with, the graph of which of the following equations is aligned with a slope of 3? So we know that linear equations are in the form y equals mx plus b. And we can take a quick look at each one of the answer choices and just identify what their slopes are. A has a slope of 1/3. B has a slope of 1. C has a slope of 3. And D has a slope of 6. So we can see that C has a slope of 3, which is what the question is asking for, and that's our answer.
Yeah, this is a pretty quick question. Just make sure you know your equation of a line, your slope-intercept form, y equals mx plus b. Here's number 8. In the equation above, which of the following is a possible value of x plus 1? So at this point, it might be good if it's confusing to think of this as a whole variable, right? Because they're asking you what is a value of x plus 1, not x, not y or anything, x plus 1. So it actually might be good to just replace x plus 1 here with y. It might be a little easier. So if we can convince ourselves here, this will be the same as saying y equals 2 over y, right? So the next step here is to solve for y, because that's x plus 1, right? So we kind of just did a little substitution. So we have y squared, if you multiply y both sides, equals 2. And very simply, if you square root that, you'll get y equals the square root of 2. So if you want to check this, this is the answer, square root of 2. If you want to check this, it's very easy to plug in. So if you check square root of 2, so we can say check square root of 2 equals 2 over the square root of 2. You can convince yourself, of course, if you multiply both sides by square root of 2, 2 will equal 2. So 2 equals 2, check. All right.
So in question 9, we're given a glass in this case, and we're given a volume associated with that container of 473 cubic meters. And the question asks, what is the value of K in centimeters? So let's write out the volume equation that's given to us. And I would like to point out that the K in this equation is the value we're looking for. And all we have to do is essentially substitute 473 for the volume. Please finish writing it, sorry.
Yep, sorry.
And since we're searching for K, we have to isolate that value. So we can multiply both sides by 48. Please use your calculator for this, of course, and divide both sides by 7 pi. And then finally, we can cube root.
I'll just skip writing that
both
step.
sides. I'm gonna throw it on my calculator right now. Apologize.
Just while Josh is doing the calculation here, realize we did not use at all in this problem, the 16 fluid ounces. This is completely irrelevant, at least for this question number 9. It might be useful later.
And we arrive at 10.11, which is
10.11.
answer choice D.
Yep. All right, thank you. So this next question here, number 10, is going to be the same glass that we have. I'm going to zoom out. So this one is a very interesting question. It requires a little more intuition than actual math. But we'll try to explain it in a way that's kind of easy to understand. So this is asking us that, you know, water is being poured into the glass slowly at a constant rate. That's important, constant rate. So we're not pouring it suddenly faster or suddenly slower. It's being poured at the same volume. We could think of it some volume per time. It's being poured at the same rate. Which of the following graph best illustrates the height of the water level in the glass as it fills? So here's one thing we can say immediately. We can cross out D, and here's why. This is saying over time, the height of the water level does not change. It's constant. We know that cannot be true because we are filling the glass. So we know it'll fill up, you know, it'll be here, and then maybe the next moment it's here, and then here, and so on. So it cannot be D. Now, we can look at A, C, and B and try to think what the differences are. A is a tempting answer because it says constant rate. So we're like, oh, it's a constant rate. There's a constant slope. This must be the answer. But we got to remember, look at the shape of our glass, right? If it were a typical cylinder, trying to draw on this pad here, trying to get used to it. If we had a regular cylinder, like a regular glass we all have at home, this might be correct, right? Because it's every chunk that you fill up, it's all the same, it has the same circular area or cross-sectional area on the way up. But if you look here, it's small at the bottom, and then it gets much bigger at the top. So we're gonna say A is not the answer here, between B and C now. So let's look at B real quick. This tells us that over time, the height is, we'll say, about exponentially increasing. It gets faster and faster, that height increase, right? So let's see if that can be true. If we look at this here, I'm gonna try to draw actually just a side view of it, so it'll really just look like a trapezoid at the bottom. Let's divide it into thirds. So this is K, the height. Let's say here and here. This is K over 3, K over 3, and K over 3. So we're not actually going to do math. It's just to show that we've divided it into thirds. If we're being poured at a constant rate, okay, so let's say we fill up this portion here. I think we can all see that this is a much bigger space to fill to get to the next height, that next K over 3. That means that'll take longer to fill, right? This tells us that the height is increasing quicker. But that can't be true. We just said it would take longer to fill this because there's more stuff to fill. Therefore, we cannot say it's B. We're going to go with C. So this one does take a little intuition to think about. Another way to look at it is, you know, again, the circle is very small at the bottom and very large at the top. So it'll fill very quickly at the bottom. If you've ever tried to fill a very small or narrow glass, it fills up very quickly, as opposed to something like a really big bucket or something that takes a lot longer to fill. All right, so we're going to move on to number 11.
11 asks, Jenny has a pitcher that contains 1 gallon of water. How many times could Jenny completely fill the glass with 1 gallon of water? So here they give us the information that 1 gallon is equivalent to 128 fluid ounces. And the figure gives us the information that the glass can hold approximately 16 fluid ounces. So in this case, we can write another proportion. 128 fluid ounces over X glasses equals 16 fluid ounces for 1 glass. And here we can simply cross multiply and have 128 equals 16x. So then dividing 16 from both sides, we arrive at 8, which is answer choice E.
Yep. Okay, important to note here, notice it's the same glass we've been looking at the past 3 questions, but now the 473 cubic centimeters is now irrelevant. We don't need this anymore. So being able to see which parts you need pretty quickly will save you a lot of time. Question 12. Okay, so we just did a question similar to this with the lawn and the bench concert. So very similar. Roberto is an insurance agent who sells two types of policies, a $50,000 policy and a $100,000 policy. Last month, his goal was to sell at least 57 insurance policies. While he did not meet his goal, the total value of the policies he sold was over $3 million. We're going to find an inequality that says the possible number of policies, they're saying X is the $50,000 policies and Y for the $100,000 policies that he actually sold last month, right? So let's write some let statements here just so we remember. Let X equal $50,000 policies, or the number of $50,000 policies sold. We're gonna let Y equal the 100, I'm gonna say 100K here just to shorthand a bit, policies sold. Okay. So just like last time with the lawn chairs, it's the exact same question. It's saying he wanted to sell at least 57, but he did not meet his goal. So that simply tells me X plus Y, that's the total number of insurance policies he sold, cannot be equal to or greater than 57. It is actually less than 57, right? He did not meet his goal, not meet goal. Again, like that lawn question, to get the total sales, how much they actually made from these policies, you have to multiply the number of policies times how much that policy costs, so that's 50,000, plus Y times 100,000. And we said that was over 3 million. So that's greater than 3 million. Bunch of zeros here. So you can just look at the choices. It's a very, very simple comparison to do. Let's look at it real quick. It is not A because this is incorrect, this sign. It is not B because this is incorrect. Let's look at C. X plus Y is 57. That matches this one. And 50,000X plus 100,000Y is greater than 3 million. That's good. And C is our answer. We don't even have to look at D. Question 13.
So if A equal 8 raised to the negative 1/2 power equals X, where A is greater than 0, what is A in terms of X? So in this case, what I would do is convert this into a simpler form that's easier for me to understand. So we know that because there's a negative exponent, we can write this out as 1 over A to the 1/2 power. In addition, we know that if something's raised to a fraction, it signifies that it's a root of some sort. In this case, it's 1/2, so it's going to be the square root. So it's 1 over square root of A. So now we want to isolate A. So to do that, we can multiply both sides by square root of A. And then divide both sides by X. And finally, we can square both sides and to isolate A. And looking at the answer choices, C reflects this.
Thank you. I'm gonna go to number 14. 14 here. All right, so this was an interesting question. Which of the following is a value of X for which this expression is undefined? So in my head, I'm thinking, okay, how do you make a fraction undefined? Especially, we're looking at value of X, right? So something in the denominator, I'm thinking. And I know when the denominator is 0, whether it's negative 3 over 0, 2 over 0, 1 over 0, we have something undefined. So I don't really care what's in the numerator here. Let's just focus on the denominator. Looking at x squared plus 3x minus 10. And we want this to equal 0. Why is that? We want it to be undefined. So the bottom somehow has to equal 0. So you can solve this with the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. That's pretty clunky. So we can also look at it and see if we can factor it. That's usually a pretty easy way to go about this. It is a quadratic, x squared, so we have 2 factors. We know I'm going to make these 2 sets of parentheses, and this is going to equal 0. That's a very bad 0. There we go. So if we look at it, I'm thinking x, let's see, plus 5, x plus 5, x minus 2 seems to work for me, just by inspection, because if you FOIL this out, right, first will get you x squared, the outside will give you negative 2x, the inside will give you plus 5x, that results in the plus 3x, and the final, the last multiplication will get you minus 10. So this is a correct factorization. At this point, to make this 0, either one of these has to be 0. If we look at the choices, there's no negative 5 as a choice. Let me just write this explicitly here. So we either need this to happen or this to happen. Condition 1 or condition 2. Either one will trigger a 0 in the denominator. And we can see here that there's no negative 5 as a choice, so we can go with 2, letter D. Let's go to number 15.
A granite block in the shape of a right rectangular prism has dimensions 30 centimeters by 40 centimeters by 50 centimeters. The block has a density of 2.8 grams per cubic centimeter. What is the mass of the block in grams? So we know that to find the volume of a rectangular prism or a box, what we have to do is multiply length times width times height, and we're given that. So we can multiply 50 times 40 times 30 to get the volume. And that's 60,000. And now we're given this density, which is, again, it gives us, in parentheses, mass per unit volume. So the density is 2.8 grams per cubic centimeter.
Grams per cubic centimeter, got you.
Here, like in previous questions, we can set up another proportion. So we can have 2.8 grams, which is the given, 2.8 grams over 1 cm cubed equals x, because we don't know the mass, over 60,000 centimeters cubed. So by simply multiplying, cross-multiplying these terms, I'm going to do that on my calculator right now, we arrive at 168,000.
All right. Cool. Yeah, this might be a concept you guys have seen in maybe chemistry or probably just chemistry, right, bro?
Yeah.
Chemistry. All right, let's go to number 16. Number 16. I'm going to zoom out just a bit. Okay, little math involved. It's more of being able to read this question. We can see they gave us a chart, so we should try to understand what the chart is saying. So let's read about this table. The table below, sorry, the table above, shows the results of a research study that investigated the therapeutic value of vitamin C in preventing colds. A random sample of 300 adults received either a vitamin C pill or a sugar pill each day during the 2-week period, and the adults reported whether they contracted a cold during that time period. What proportion of adults who received a sugar pill reported contracting a cold? Okay, that's a lot packed in there, but it's actually, the question is asking is very, very simple. What proportion of adults who received a sugar pill reported contracting a cold? So we are looking at only the adults who received a sugar pill. So let's look at this here. This is vitamin C. We don't have to look at it. This is total. We also don't have to look at it. Right? So now we've just narrowed down our table to just one line to look at. What proportion of them reported contracting a cold? Well, here's cold. I'm gonna use a different color here. So 33 of them reported contracting a cold. The total was 150. So just using these three numbers, 33 got a cold over 150 sugar pills, total people who took the sugar pill rather. And if you simplify this, in my head, I'm just dividing everything by 3. That gets me 11 on top and 50 on the bottom. You can use your calculator probably to simplify this as well. That will match our answer here, answer choice B. All right, let's go to 17.
Okay, so the table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of mean, median, and mode of the ages? So very quickly, I'd like to go over the definitions of each of these. So the mean is defined as the average of the values. And the median is essentially the middle value of the values if they were, listed in order in sequence. And finally, the mode is defined as the most common or the most frequent value that we see. So very quickly, we can identify that the mode would be 18 because you can see at the first entry of the chart that the frequency is the highest, 6. For the median, we can think that we have 20 students. So what would the middle of 20 students be? That would be between the 10th and 11th student. So we can quickly just sequentially count the students, and we can say that there's we can remove the 6 from the age 18, and then we can see that the 10th and 11th value both fall in the 19 age range. So therefore, the median of this is 19. And finally, to calculate the mean of this, we can simply we multiply 18 times 6 plus 19 times 5 plus 20 times 4 plus 21 times 2 plus 22 times 1 plus 23 plus 30, and divide all those by the number of students. And doing the math on your calculator, you arrive at 400 over 20, which is 20. And here, now that we have all three of these values, we can quickly see that the mode is less than the median, which is less than the mean. And that the answer choice that reflects this would be A.
Awesome. We're going to move to 18. Okay, another graph they're giving us, so that means we should think about how, what is this graph showing? So let's see. The figure below shows the relationship between the percent of leaf litter mass remaining, so that's the y-axis. Maybe I'll use a different color there. Sorry, here we go. Remaining after decomposing for 3 years, and the mean annual temperature in degrees Celsius in 18 forests in Canada. So those are all these points. Those are the data points. So this is asking us now, in this particular forest, so whose data is not included in the figure, that means it's just not one of these dots right now. It had a mean annual temperature of -2 degrees. So let's see, this is 0. Make sure you're reading your axes properly. This is -5, so this is -2.5. So we're looking around here or so. It doesn't have to be, it doesn't have to be super exact, but we're looking right about here. It's asking us, based on the line of best fit, which is this black line that goes through all the data, which of the following is the closest to the predicted percent of leaf litter mass remaining after decomposing for 3 years, which is the y-axis. So this is simply asking you, can you go up from -2, hit the line, and then read across, and we get 70%. And just like that, got the answer. Let's go to number 19.
So for number 19, it asks that the range of the polynomial function f is the set of real numbers less than or equal to 4. If the zeros of f are -3 and 1, which of the following could be the graph of y equals f of x in the xy plane? So first, I want to take a look at the portion where it says the zeros of f are -3 and 1. Now, what this means is these are the root values, and they're essentially the x values at which y equals 0. So we can quickly take a look at the answer choices and see that A, C, and D all reflect this. However, these roots are -1 and +3, and that's not what we're looking for. So we can remove this from our choices. And now let's take a look at the range. It says that the range of these numbers is less than or equal to 4. The range is essentially the values of y. So for answer choice C, we can see that the range is actually -4 and above, and that's not what we're looking for. It has to be less than or equal to 4. In addition, D also exceeds 4, right there. And so that leaves us with A, and we can verify that it indeed has its y values less than 4.
I'm trying to get that line on that 4 there. There's the 4, and everything is below 4. There we go. Awesome. Let's go to number 20. Another modeling question. Looks like I'm getting all the modeling questions today. So the average annual energy cost for a house is $4,334. That's annual. It's every year. The homeowner plans to spend $25,000 to install a geothermal heating system. The homeowner estimates that the average annual energy cost will then be $2,712. So a decrease from the original cost. Which of the following inequalities can be solved to find T, the number of years after the installation, at which the total amount of energy cost savings, that's important, cost savings, will exceed the installation cost? So let's do a couple things here. We know what the installation cost is. It's $25,000. So we could start writing that. $25,000 is the installation cost. Now it's asking us, how many years will it take for the total amount of cost savings? So let's do 1 year, right? 1 year cost savings, is 4,334 minus 2,712. I won't actually do that math because if you look at the answers, they don't simplify that answer. So let's just leave it as these raw numbers that we have. So this is 1 year of savings. What would happen in the second year? The cost savings would be this same number because you saved this in the first year, 2,712, plus, again, 4,334 minus 2,712. In other words, just, simply put, 4,334 minus 2,712 times 2, because you saved that much for 2 years now. So if I said T years, how much would you have saved in T years? I think it is if you're able to convince yourself, it would be the same difference here, cost savings for 1 year, and you would simply multiply that by T for how many years you've been using this new geothermal system. So this asks us which inequality can we use to figure out when it would start exceeding the installation cost. So when this here would start exceeding this. So let's do that real quick. 4,334 minus 2,712 times T, some inequality symbol, 25,000. So it's asking us when would the savings, so let me write here, this is savings, this is installation, I'll call it installation cost. We want to exceed, so that would be greater than. I think that leads us to answer choice B. The answer looks flipped, but I just have it written the other way, so that is the same answer choice as choice B. All right, number 21 to Josh.
All right, so here we're given another graph. So it says between 1985 and 2003, the data were collected every 3 years on the amount of plastic produced annually in the United States in billions of pounds. The graph below shows the data and the best line of fit. The equation for the line of best fit is y equals 3.39x plus 46.89, where x is the number of years since 1985, and y is the amount of plastic produced annually in billions of pounds. The question asks, which of the following is the best interpretation of the number 3.39 in the context of the problem? So the line of best fit is given to us, and it's in the form y equals mx plus b. So the 3.39 in this equation is the slope. So now when we're looking at these answer choices one by one, we're going to look for the answer that most accurately aligns to the definition of the slope. So here, A says the amount of plastic in billions of pounds produced in the United States during the year 1985. And that clearly isn't it, because that's simply the value, the Y value at that certain time. For B, B says the number of years it took the United States to produce 1 billion pounds of plastic. That one, again, it's just the number of years it took the United, that's just, it's a certain number, it's the X value essentially on the X axis. So that can't be it either. For C, the average annual plastic production in billions of pounds in the United States from 1985 to 2003. Again, this one identifies a average of the Y values, and that clearly isn't it. And finally, D, we have the average annual increase in billions of pounds of plastic produced per year in the United States from 1985 to 2003. And that indeed does reflect the slope of the equation.
Just to follow up, right, the slope is rise over run. So it's really the change in the amount of plastic versus, I'm gonna get to scroll down a little bit here.
Versus the number of years since.
Yep. So, you know, the average annual increase means basically how much are you increasing per year, right, in billions of pounds from these years. So this is the best interpretation of that. Let's go to 22, referring to the same graph here. Which of the following is the closest to the percent increase in the billions of pounds produced from 2000 to 2003? Let's do a quick recap here. Percent increase, or percent change really, I should really call it percent change, is equal to the new value minus the old value divided by the old value. And then you would just make that a percent times 100%. So one thing to look out for here is you will not find 2000 or 2003 in here in the x-axis because it's number of years since 1985. We can kind of do some mental math and say, well, 2000 is 15 years after 1985. That's this point right here. That's 2000. The year 2000, not the value, 2000. And 2003 would be 3 years after that, or 18 years after 1985. This is 2003. So it's asking us what is the change in the billions of pounds of plastic produced. So there's two ways to do this. There's kind of the inspection way, and then there's more of the, you can use this line of best fit type of way. We're just gonna do it by inspection. It's actually relatively simple to do. So if we look here, that's pretty much 100. This 2000 value is pretty much 100. So let's start doing that. So that's, actually I have to start with this, right? New minus old, new minus old. So something minus 100 over 100 times 100%. Let's look at that new value. That's 2003, right? So how'd that change? If you look at it, it's not quite halfway between 100 and 120. So it's not quite 115. So something less than, we can pick 110, right? Because just, this is 115 over here, slightly less.
Sorry, I wanted to interject. That's 110.
Yep. What was that?
Oh,
sorry, yes, sorry. That's 110. So maybe a little less, but again, we're doing a close estimate. So 110 is actually pretty good, a little less. You could say 108, 107. So that's up to you. 110, we'll see. So I just circle it just so we know that's the one we're not super sure about. But even then, when you do the math here, 110 minus 100 divided by 100. So what we see here is about a 10% increase. We can do that. 10 over 100 is 0.1 times 100% will give us about a 10% increase. So that gives us answer A here. And again, if you'd chosen 8 or 9%, or sorry, 107 or 108 or something, you would have gotten 7 or 8%, which you would have known these were way too high. Way too high. So you would have still been correct to choose really 107, 108. You would have still ended up at this answer. Let's go to 23.
All right, so 23 gives us a equation m equals 1,800 times 1.02 to the t. So it says the equation above models the number of members m of a gym t years after the gym opens. Of the following, which equation models the number of members of the gym q quarter years after the gym opens? So here, understand that a quarter of a year is 1/4 of a year, of course. And we really have to, what the question is basically asking is converting this m equals 1,800 times 1.02 to the t, converting that into quarters rather than t years. So we really have to inspect the relationship between t and q in this case. So let's quickly say that q equals 1, let's say. And that would be 1/4 of a year, so 0.25 t. Second quarter, we have, it's 2 quarters is half a year. And in the same manner, 3 is 0.75 and 4 is 1. So the relationship here is that 4 times t essentially equals q.
But for q equals t?
No, it's 4t equals q.
Oh, sorry, my bad. Yep. 4t equals q. Yep.
So now that we have this relationship, we can try to put this back into the original equation that we have. Let's quickly divide both sides by 4 to isolate t so that we can plug it straight into the original equation. And so then we arrive at t equals q over 4. And then we can plug that straight into the original equation, and the answer that reflects that is A. So here I advise to actually work it out rather than rushing to a answer choice, because there's actually answer choices like B that could really confuse you. And you won't know whether or not it's 4q or q or 4. So by working it out this way, by analyzing the relationship between these two values, we can arrive at this answer.
Yep. And Josh, do you want to go through just a quick sanity check?
Okay, let's
plugging in some numbers.
If you guys need just reassurance that you guys got the right answer, let's say that we're doing let's do 1 year. So in that case, m would equal 1,800 times 1.02 to the first power. So you don't even have to write it. 1 year would be equivalent to 4 quarters. So let's plug that into our answer choice. That would be 1,800 times 1.02 to the 4 over 4, which is equivalent to 1. And now we know that we have arrived at the right answer.
Yep. All right, let's go to number 24. 24. This is a bit of a tricky question. If I were doing this on the actual exam, I probably would skip it first and then come back to it later. But we're here for about an hour and a half, so we're gonna go through this problem right now. It's not really a math question. It's more of a, can you make a conclusion from something type of question. So let's try to read it. A lot of percentages here. You can see there's this, there's that, there's this, there's that. So we're gonna try to break it up and see if we can try to make sense of it. So for some TV show, there's this finale where the viewers can use social media or text messages to vote. So let's just remember that there's two contestants, two ways to vote. 2 ways to vote, and that's social media and text. The contestant receiving more than 50% of the vote won. So whoever gets more than 50%, they're going to win. That's pretty simple. An estimated 10% of the total viewers voted, right? So if there were 100 people that watched it, only 10 of them had actually voted. So I'm gonna make a little pie here. We're going to say this pie represents all the people that voted. I'm gonna make it a little bit bigger. This is gonna get a little messy. So this whole pie is all the people that voted. All the people that voted. It says 30% of the votes were cast on social media. I'm gonna color that in green here. Social media was about a third. That's 30%, almost a third. Let's say about there. This is social media. 30%. So without going ahead, without reading the rest yet, I think we can guess, because there's only 2 ways to vote, social media or text, that the rest of this has to be by text. We can say that has to be 70%, right? Because this has to add up to 100%. We have to account for all the voters. So at this point, it asks us, or it tells us, contestant 2 earned 70% of the votes using social media. So I will do that in a completely different color here. Let's use this nice pink. Contestant 2 earned 70% of the votes cast using social media. So of this green portion, this 1/3 right here, of this portion, contestant 2 got 70% of these. I could also tell you contestant 1 got 30% of these. Again, that's of the green portion of the social media. Likewise, 40% of the votes cast using text message, we can say contestant 2 got 40% of these in the blue, and contestant 1 has 60%. Again, everything adding to 100 here. Based on this information, which is an accurate conclusion. So that just means maybe some of them aren't, maybe it's a bit of a stretch, maybe you can't quite infer it. So I'll have to think about this a little bit. So let's read through each answer choice. And if we have any doubt, we can't pick it, basically. Doesn't mean it's wrong yet. We don't have to eliminate it, but it'll give us an idea how to proceed. So let's go choice A. If all viewers had voted, contestant 2 would have won. Well, we know that only 10% of people have voted. So can we infer that if all viewers had voted, I don't know why that control symbol is. Can you see that control thing there, bro?
I don't.
Interesting, okay. Maybe it's glitching on my screen. So if all viewers had voted, so we said, assuming there were 100 viewers, 10 voted. If the other 90 had voted, contestant 2 would have won. Easily in your head, you can discount that because what if those people had voted for contestant 1? Like, we don't know how those people are going to vote. This might not represent the entire viewers, right? All the viewers. So we can probably say no. Not going to officially say no yet because this is which was most accurate type of question. So viewers voting by social media were likely to be younger than viewers voting by text message. Let's look at this passage again. Nowhere does it talk about being younger. This is kind of a choice to kind of trick you. I will definitely say no to choice B. If all viewers who voted, so that's again those 10% of viewers, had voted by social media instead of by text message, contestant 2 would have won. So this is, let's look at this pie chart here. What C is kind of trying to say is, well, look at social media. Contestant 2 got the majority of it. Therefore, if everyone who texted also voted by social media, then contestant 2 must have won. That is not necessarily true, right? They might not be the same people, the people texting versus voting by social media. So we don't know, we can't really infer that. It is quite a stretch. It is quite a stretch. So like a maybe no on the side here. Last one, viewers voting by social media were more likely to prefer contestant 2 than were viewers voting by text message. Ooh, this is interesting because viewers voting by social media, that's this green portion, were more likely to prefer contestant 2. That's true, right? Everyone who voted by social media, 70% of them voted for contestant 2. Then were viewers voting by text message. Well, voting by text message, contestant 1 was actually winning. So that is also true. Contestant 2 was less likely to win the texting voters as opposed to the social media voters. So this is literally a restatement of everything in here. So this is the best conclusion. I think this does take a while to kind of go through. So like I said, this would have been one I would have maybe also saved to the end of the exam. But hopefully that made sense. And now we're going to move to number 25. As I try to click and can't. And I still can't click. 1 second. Hold up. I'm having trouble clicking right now. 1 second. There we go. I think. There we go.
Cool. All right, we're given a table here, and the table above shows the population of Greenleaf, Idaho for the years 2000 and 2010. If the relationship between population and year is linear, linear being the key word, which of the following functions P models the population of Greenleaf T years after 2000? So because it said that this the relationship is linear, in your head you can go back to the slope-intercept form, y equals mx plus b. And to really visualize what's given here in our table, we can draw a really quick graph, if you don't mind.
I'll try to.
And we can see that in the year 2000, just draw a arbitrary point on the time x-axis of 862, and 2010 we have 846, which decreases. We see a decreasing trend.
846. Notice also I put 2000 over here because this is T years after 2000. So
yeah, so it sets that as the initial point.
Right, so that's actually T equals, sorry, I'm selecting things I'm not intending to here, 0. And then over here we have 10 years after.
T equals 10, so that would translate to 2010.
Right. We'll try to draw a straight line.
So this is how I would visualize it. And of course, to calculate the slope, we have rise over run again.
Yep.
So we have the population change between 2000, 2010 is minus 16 because it decreases 16.
Yep. Let me just write it. So it was 846 minus 862, right?
No, it's 8. Yeah, okay. Yep. 846 minus 862 over 10 years, which is the difference between 2010 and 2000.
Yep.
And that gives us a value of 1.6. So we know that 1.6 will be our slope.
Negative?
Negative 1.6, sorry. And so we look at the answer choices and we see that there's also a initial condition. So in our visualization of this graph, we see that 862 is the initial y value, which is the b in mx plus b. So therefore, we can write this equation out as y equals negative 1.6x plus 862. And now we can simply search for the answer choice that reflects this. And we can see that A is the answer to that.
Yep.
And make sure to, pay attention to where that decimal point is. I almost got confused here for a second.
Yep. That's a 16. There's a 16. Yeah. And if you guys, when Josh was talking about the initial condition, basically that means initial meaning time equals 0. And if you plug into here, time equals 0, or in our case, x equals 0, you will see this will just cancel out to 0 here.
And we get the y-intercept in this case.
Right, you'll get the y-intercept of 862, which is our initial problem. So this solves the problem. It's a good model. Okay, let's go to 26. Only a couple of questions left down here. Way more than halfway already, actually. Oh, another surveying type question. Okay, to determine the mean number of children per household in a community. Again, no math here, no math. Tabitha surveyed 20 families at a playground. That's important. Families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. So let's just write mean equals 2.4 children per household, which must be true, right? So let's see. We got to read through the answer choices here. There's no way to just solve the problem. So let's go through all the choices. So choice A says the mean number of children per household in the entire community, is 2.4. You might be tempted to choose it because they literally just told you in this community, she surveyed people at a playground and she got 2.4. So it's got to be 2.4. However, we have to be able to discern this sort of sampling bias, right? That's kind of like a fancy word for it. In other words, it's not a representative sample. If you're surveying people at a playground, I think we can probably guess that kids will be at the playground. People aren't just going to the, elderly, for instance, elderly folk will not be going to the playground. We are going to be seeing people with their kids at the playground. So that means the mean might be higher because these are kids the families were surveying at the playground. So it's not representative, right, of the whole community. So it might be true, but we cannot say it must be true. B says a determination about the mean number of children per household in the community should not be made because the sample size is too small. So this seems pretty convincing. We don't know what the community size is, however, right? What if the whole community was, let's say, 80 families, right? We have a quarter of them at the playground right now. Is that too small? Maybe not. You're surveying already a quarter of the entire population. That's, for the most part, that's usually pretty good. So we'll put a maybe no here because not super certain, but this at least tells us something might be wrong. Something's not right. C says the sampling method is flawed. So it's saying it is very flawed. It may produce a biased estimate of the mean number of children per household in the community. Well, those are pretty much the exact words I said when we were reading this at first, that this is some sort of sampling bias. I will write it here, sampling bias. Just to explain this concept again, you're basically saying, you took this small group, and you're trying to say, oh, I found the mean was 2.4. Therefore, for the entire community, it must also be the same. That is a big jump. This arrow right here, I'm gonna circle in green. This arrow was a very big jump. So C basically tells us that jump, that gap, not good, not good. So right now I'm leaning towards C. We'll just read D real quick. The sampling method is not flawed. I'm pretty sure that's wrong already, and is likely to produce an unbiased estimate. So this is exactly contradicting what we just said. So we're not going to go with that. And if we just compare again B and C, B is very forceful. It's saying this you cannot determine the mean because the sample size is too small, versus this one that says versus C, which says it's flawed and may produce a bias estimate. So this is a little bit better.
I would like to add that B attributes this this problem solely on because the sample size is too small. For C, it says that the method in general is flawed because, for example, households don't have to contain children because those, let's say a household doesn't have any children, they would not be present at the park.
Right.
So that's why this sampling method is flawed, and that's why we can safely assume that C is the right answer.
Good, thank you. Let's go to 27.
All right, for 27, in the XY plane, the point PR lies on the line with equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r, lies on the line with equation y equals 2x plus b. If p is not equal to 0, what is the value of r over p? So here they give us two separate equations, so let's work them out one by one. So the aim here is to essentially combine these two equations, and the only way to do that is by solving for b for both equations. So first things first, what I want to do is plug in the values of PR into each of the equations. And so for the first equation, we plug in the point P for X and R for Y. So we have R equals P plus B. In the same manner, for the second equation, we can plug that in and we can get 5R equals 2 times 2P plus B. And let's quickly multiply that out and get 5R equals 2P plus B.
4P?
4P plus B, sorry. And now let's quickly solve for B. So for the first question, for the first equation, we can simply subtract P from both sides and get R minus P equals B. And for the second one, we can do 5R minus 4P equals B by subtracting 4P from both sides. And so now that we have B isolated, we can set these equations equal to each other and essentially taking out the B altogether. So now we have R minus P.
Oh, let me do it in the right color. Sorry,
sure.
1 second. Grab that blue. Okay.
You have R minus P equals 5R minus 4P. So now the question is asking for R over P. So essentially what we're trying to isolate is the term R over P. So in order to do that, let's combine like terms. And let's say I want to subtract R from both sides first. And that eliminates that. And negative P equals 4R minus 4P. And then now we can add the 4P to the other side, to both sides. So that cancels out. And then we have 3P equals 4R. Now this is asking for R over P. So we can quickly divide both sides by P. And now we're getting, we're inching closer towards that final R over P.
Yep, I'm going to circle it for you right there. Yep.
And then we can divide both sides by 4. And have 3/4 equals R over P, which is answer choice B. There it is.
Yep. All right. All right, number 28. Well, about 10 questions left here. With about 20 minutes left. Let's see. Hopefully we'll have time for some Q&A, but we'll see. So in this question, you're given this. I cannot find my drawing. There it is. Okay. In this question, we're given these two graphs, two frequency plots, basically, where 22 students in the class conducted an experiment recording their pulse rates in beats per minute before and after a light exercise. So they're the same students just before and after exercise. The dots The dot plots below display the results. Let S1 and R1 be the standard deviation range of this one before, and S2 and R2 for the second one. Which of the following is true? This is a pretty straightforward problem. I will just start with the S1 first. S1 is standard deviation. There's a pretty fancy formula for it. It's having to do with how far the values are from the mean. It basically means how spread out your data is. So let's look at something real quick. This data is like this bell shape, and you guys are probably pretty familiar with this bell shape type curve. That means more of the values are squeezed to the mean in this middle kind of 72 area right here. There's a couple of them on the outsides, like this 88 and 56. Let's look at this one at the bottom. After exercise, it's pretty straight. Like we can't really tell what that is. That's more spread out. That data is more spread out. That tells me it cannot be A, okay? If it's more spread out, the standard deviation also has to be greater in that second one. So it can possibly be B, it can. It cannot be D. And not equal is a much more general term of just saying they're not the same spread. So let's see, it's either B or D. The range will tell us. Range, again, is simply the largest value minus the smallest value in the data set. So in the first one here, we have 88 minus 56, which gets us 33, range 1. Let's look at range 2. Range 2 is 112, yikes, 112 minus 80. Sorry, this is 32, my bad. 32. 112 minus 80 is also 32. That is the same range. So that tells us it's got to be this one. So by default, our answer has to be D. Let's go to 29.
All right, for 29, a photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate, so emphasis on constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine at minutes after the machine started printing? So P is the remaining value, and M is the minutes after the print starts. So it tells us that for this, after 20 minutes, it has used 30% of the paper. That means that the leftover paper at that 20-minute mark is 5,000, which is the initial value.
I'll do a chart like this, bro. So minutes and P, right? 0 minutes, we have 5,000 sheets.
And then at minute 20, we have, that would be, it says the machine uses 30% of paper, meaning that the remaining value is actually 70%. So multiplying that out, we get 3,500. Now, because this question asks for, says that the printing happens at a constant rate, we can assume that the answer would be taking on a linear form, thus eliminating C and D, which is an exponential form. Sam, if you could just draw a quick exponential.
Yep, I believe both of them.
Because it's a fraction, it would be decreasing. Yeah.
It'll kind of start at 5,000, which is great, 5,000, but it'll kind of look, let me get a different color here. It'll kind of look more like this. Exponential decay, which is not
that wouldn't be a constant rate, exactly.
Yep.
So let's take a look at answer choices A and B. We can see that after 20 minutes, we can try to arrive at the same 3,500 remaining answer. That 5,000 minus 20 times 20, 5,000, which is 400, right? 5,000 minus 400 is 4,600, and that's not equal to 3,500.
Is it 4,600?
It's 4,600, yeah.
Okay.
So for answer choice B, we have 5,000 minus 75 times 20 minutes, which is 1,500.
But 1,500 for this, right?
Yes, for that value. And then the P would be 3,500. So in this case, our answer would be B. Yes. And really, if you're not convinced about answer choices C and D, you can also plug in values in the same manner. let's set minutes to 40, so double the time.
Yep, let me write it here, 40.
And we know that by following the trend, we know that the machine would use up another 1,500 sheets of paper, leaving us with 2,000 remaining. So here, if we plug in 40 for those, it would essentially, that m over 20 would equate to a squared 2. So in those cases, by just using your calculator to double check, you can see that you don't arrive at that answer at all. And therefore you can eliminate those.
Also, again, we're in the calculator section, so Josh has mentioned this. If you graphed, we showed you guys this graph over here. You can very quickly graph all of these on the graphing function on your calculator, and you can very quickly tell this is not linear. Cool. 30 looks like we'll about 8 or 9 questions left. Let's see if we can do it. This is a pretty simple question. The complete graph of function f and a table of function g. So this is f. We're looking at f here. This is function f. The maximum value of f is k. The maximum value of f is k. So this is f. I'm seeing a maximum value right here. So k is 3, right? K is the maximum value. What is the value of g of k? So if I'm not mistaken, all we have to do here is say, okay, k is equal to 3. What is g of 3? That's all I was asking. What is g of 3? And if you go here, g of 3 should be 6, which should get us answer choice B. And that is all. Number 31, easy problem there.
All right, so this starts the portion of the exam where on the answer sheet, it would be a box of answers followed by filling in the number values corresponding to each box. So in this case, we're given 2 atoms of hydrogen and 1 atom of oxygen are in 1 molecule of water. How many atoms of hydrogen are there in 51 molecules of water? So it's basically a common theme at this point that we can set up a proportion. So we know that it's asking for the number of atoms of hydrogen. So we can have 2 hydrogen atoms per 1 molecule of water equals X number of hydrogen over 51 molecules of water. So by simply cross multiplying again, we can get 102 atoms of hydrogen.
Awesome. Yeah, simple question. 32, another pretty easy question here, just some basic algebra. If x equals 1, they're even telling us like what x is here. What is the value of a? So let's do that real quick. Let's rewrite x minus 1/2 a equals 0. They said x equals 1, so let's plug in 1 for x. 1 minus half a equals 0. You could do this by inspection and say, you know, this has to be 1 minus 1 equals 0, or you could work it out and say, well, 1 just by adding 1/2 a to both sides has to equal 1/2 a. Multiply both sides by 2, and you'll get that a has to equal 2. And that is it. Pretty easy question there. Moving right along to number 33.
Right, number 33, in the xy plane, the equations x plus 2y equals 10 and 3x plus 6y equals c represent the same line for some constant c. So we know that they have to be identical. So what is the value of c? So we can't really work with this form that it's currently in. So let's try to convert it to our y equals mx plus b. So the first equation converts to simply by subtracting x from both sides and then dividing everything by 2. Let's do that one step by step.
Yep. So 2y equals
10 minus x.
10 minus x.
And then dividing both sides by 2. You get
y
equals 5.
I'll just do it this way. Put the mx plus b.
Sure. Plus 5. So we'll do the same thing to the other one.
Yep.
And we can subtract 3x from both sides. 6y equals c minus 3x. It's the same thing. Okay. And then by dividing 6 on both sides, we get y equals negative 3 over 6, which is equal to 1/2 x plus c over 6. So here we can take a look at these two equations that we have, and we can see that that their slope is the same, but the only term that's not the same right now is that 5 and that c over 6, and we have to get those equal. So we can quickly set c over 6 equal to 5. And then by multiplying 6 on both sides, we get c equals 30.
Again, Josh is doing this because they said it's the same line. So to have the
So they
same
have
line,
to
you
be
have to
identical.
have, right, same mx plus b, basically y equals mx plus b. 34. All right, pretty easy question here. Paul Revere, useless information, traveled 11 miles in 26 minutes. What is the average speed? So again, that just, he didn't have to travel the same miles per hour, basically, in each leg of the journey. This is just saying he did 11 in 26. So to get the average, it's just dividing, right? So you're just saying 11 miles in 26 minutes. Now here's the thing, we want it in miles per hour. So I'm gonna hold up on this number. Let's do a little bit of conversions first. I'm gonna do a proportion. That's how I see it best. So we have per hour, miles per hour. We want to change minutes to hours. We know there are 60 minutes in 1 hour, at least last I checked. And we have 26 minutes in X hours, right? We don't know what that is. So let's do that multiplication. Bro, if you don't mind doing that for me real quick. That's 60x equals 26. X equals?
60 divided by 26 divided by 60
yep.
is 0.43.
0.43. Quick sanity check. We know half an hour, that's 30 minutes, is 0.5 of an hour. That's literally in the name, half an hour.
And this is slightly less, yes.
Yeah, 26 is slightly less than a half hour, so this is good. That's all we got to do here. We have 11 miles per 0.43 hours, which if you can calculate that for me once again.
25.58.
25.58, you said?
Yeah.
We got to chat. We have time for one more question. We have to wrap the program. Thank you. So yeah, we'll do one more question after this, and then we'll have to wrap this up. Almost at the end, so we will be continuing. We'll add kind of like a last recording so that this will be available through the library. So if you wanted to get this to the nearest tenth of a mile, you would just have to say 25.6. Now, my understanding, I think, is I have 25.4 written.
It's because I rounded the 0.43 value I gave you.
Yeah, so this, you just got to be careful. This got rounded. So if you didn't round it and used the actual value from your calculator,
just 0.433333.
Yeah, you would actually get 25.43333, which you would actually get to 25.4 is your answer. So just keep that in mind. Try not to round calculators. We kind of made that common mistake there. So watch out for that. Don't round too early. Don't round too early. All right, one last question by Josh.
Okay.
And then I think Cecilia will come back and kind of wrap us up here.
So they give us this parabola defined by f of x equals -1/2 times x minus 4 squared plus 10. And they also give us, not shown, another function. It's -x plus 10. What is one possible value for a such that f of a equals g of a? So what we're thinking here is that we're trying to find the intersection between these two functions. So you can either take advantage of your calculator, or you can even graph it straight here. It's not shown, so why don't we graph it? So we know that the y-intercept is 10, so let's just mark that quickly.
Yep, I'm going to use blue here, red. Actually.
And again, here I would like to point out that you really have to pay attention for the amount of the tick marks of the axes. So in this case, 1 is 2 boxes to the right. So you know what the slope is -x plus 10, meaning one value down and one value to the right.
So one value down is here, is 9. One value to the right is actually 2 boxes.
So it's 1.
Here.
And then we can continue that line all the way.
Sorry, I don't know what's going on. There we go. We could keep drawing these dots. And we found the intersections if we drew this line down here.
There's an intersection at x equals 8 and an x equals 2. And you can put either of those as your answer.
Right. So your answers can be a equals 8, which is this value right here where it intersected, or erase this to avoid confusion. 2 A equals 2. Both of these answers should work. So hello, everyone. This is us just continuing the last 3 questions of our SAT review here. So I'll start sharing my screen again. Here we go. And this is question 36. Just to check, you can see my screen, bro?
Yeah. Can you please go back to 34? I just want to clarify one more thing.
35, maybe you meant?
34.
34.
So the actual calculation was when we divided 26 by 60, that was 0.43333, continuing.
Ah, okay.
That's what I missed earlier.
333. So yeah, it's just correction to an earlier problem that don't round too early, use your calculator, you will get this answer.
And then finally the answer that you're gonna round is 25.38 actually.
Ah, okay, so my bad. So this will not be here, it'll be 20.
There's just a misunderstanding before.
25.38. This is just a double check with your calculator. You'll get about this answer, and then when you round it, you want to the nearest tenth. That's why 25.4.
Cool.
Okay, let's do 36, 37, 38. 36 is a trigonometry type problem. You can do it sort of brute force trial error, or you can use a very clever trigonometry rule. So this is saying in this triangle above, point W not shown lies on RT. We don't know where it is. It could be here, it could be here, it could be here. We don't know. What is the value of the cosine of RSW minus sine of WST? So let's just pretend it's over here. This is W for us, W. And we're gonna draw a line here. So we have this angle RSW, that's here, and WST over here. So let's do it the clever way first. The clever way is this. We have to remember this rule that if you have some cosine of x, it is equal to the sine of the complement being 90 minus x, right? If you need to convince yourself, we can try this. Cosine of 60 degrees, is it equal to the sine of 30 degrees? If you use your calculator, or if you're familiar with your 30, 60, 90 triangles, or if you want to, if you just remember these rules here, sine of 30 is a half. Cosine of 60 is also half. This works. You can try with anything.
I would like to note here that make sure your calculators are set to degrees, and because we're using degrees here and not radians. Okay.
Calculator set to degrees. Thank you.
And if you want to use radians, of course, convert accordingly.
Yeah, you can use radians, 30 degrees would be the pi over 6, I think. 60 degrees is pi over 3. I prefer to use degrees. It's a little more intuitive to understand. So if we are using this rule here, the answer pops out immediately. Cosine of x, so we'll say this is x here. This right here is x. This is 90 minus x. And we know this because this is a 90-degree angle. So if this is x, this has to be 90 minus x. So that is this right here. This is 90 minus x. Well, if you look at the rule, they're the same. So if they're the same and you're subtracting them, it has to equal 0. So 0 is going to be my final answer. Now, if you're not convinced, we can try it with some numbers here. Let's pretend you drew this line here perfectly so that this angle was 45 degrees and this angle was 45 degrees. If you actually tried the math out, same answer. You would also get 0. It would be cosine of 45 minus cosine of 45. Let's say you didn't draw 45 and 45 and you drew maybe like a 20-degree angle and a 70-degree angle, right? It has to equal 90. If you do it on your calculator, cosine of 20 minus sine of 70, you'll also get 0. So you can plug in a reasonable number here and you'll also get the same answer of 0. 37, Josh?
Right, we're given a table accompanied by a graph here. So just a little blurb to describe what it is. When a patient receives a penicillin injection, the kidneys begin removing the penicillin from the body. The table and graph show the penicillin concentration in a patient's bloodstream at 5-minute intervals for 20 minutes immediately following a one-time penicillin injection. So according to the table, how many more micrograms of penicillin are present in 10 milliliters of blood drawn from the patient 5 minutes after the injection than are present in 8 milliliters of blood drawn 10 minutes after the injection? So the key word here is the word more. So you know that there's like either an increase or a decrease, and it's essentially telling us that we're looking for a difference. So let's first look at the first part where it asks 10 milliliters of blood drawn at 5 minutes after the injection. So Sam circled the values, and we can see that present, the concentration in, and pay attention to this, the micrograms per milliliter is 152 milligrams per milliliter at that time. So now, because it's asking for 10 milliliters of blood, we actually have to set up a proportion to essentially multiply this by 10. That's what the effect would be. So that, and then we get 1,520 micrograms in these 10 milliliters. So we can do this, we can use the same method over towards the, to the second portion, where we have 8 milliliters of blood drawn 10 minutes after the injection. So at 10 minutes, we have actually 118 micrograms per milliliter, which is equivalent to X over 8 milliliters. So if we multiply 8 by 118, we get 944 micrograms. So now we have these two values, and we can now get the difference between them. So we can subtract 944 from 1520 and get 576 milligrams, which is our final answer.
Micrograms.
Micrograms, sorry.
Yep, micrograms. This symbol here is micro, 10 to the minus 6. 10 to the minus 6. All right, and finally, last question here. It is the exact same setup of the question, so I'm just going to scroll down to the problem here, saying that the penicillin concentration in the patient's bloodstream T minutes after the injection is modeled by this function here. So we will write P equals 200 BT over 5. If P approximates the values in the table within 10 micrograms per milliliter, what is the value of B rounded to the nearest 10th? So it's basically saying, can we figure out what B is? And yes, we can. We have a bunch of values to try to figure it out. So let's start with this. Does this first value, if we plug in 0, this is minutes after injection, right? So that's that T over here. If you plug in anything to the 0, you're going to get 1. So this is what not to do. This is not great. It's not wrong, but it's not great. It doesn't give us more information. If you had plugged in B to the 0 over 5, you get B to the 0, which equals 1. Well, that's right. P equals 200 is correct. That's correct. But we have no idea what B is still, because anything to the 0 is 1. So let's not use that. So let's not do this. Let's try the second point, T equals 5. This might get us somewhere. Scroll down here. So for 5, changing to my red pen, 152. So we plug in the values. 152 equals 200 times B to the 5 over 5, because it's 5 minutes after the injection. Now this is 1, but we still have B, which is really good. 152 equals 200 B. And this is a simple solve for B problem now. So now we get, if you divide both sides here, let me just be thorough. Divide by 200, you will get that it equals 0.76. And it's asking us, if we remember in the question, to round to the nearest 10th. Finally, our answer is 0.8. If you need to double check your answer, you can use this new equation you have now, P equals 200 times 0.8 to the T over 5, and try it for all these other scenarios and see if you're getting it within this 10 micrograms per milliliter. So the final answer is 0.8. And that will conclude the entire math section, section 4, for our review today.
Thank you.
Thank you.
Thank you again for attending today's program. You can find more program, the team program at our homepage. And thank you for attending. So I hope everybody has a great weekend. Thank you.